I'm going to show you a pretty neat application of rational functions. By the way, after we do this little application, you'll have a flex question. So we've kind of got two things on the agenda, but a little application of rational functions. It's kind of one of those things where you should say when we're done, oh my, yeah, I can see how that works using a simple fraction equation. Now we call them work problems. Work problems are actually problems where you have like workers, I should say two or more workers working together trying to complete one whole task. Oh, kind of like that swimming pool sort of goofy intro where you had two things that were working together. Actually, they were working against each other, but the point is they were kind of working at the same time to complete one task. And actually, I think I have that up here for those that like to see little definitions. We technically call it the combined effort of two or more workers. You'll get the idea of what I mean by a combined effort. Okay, so they're kind of specific, again, where we have at least two or more working together. And we're trying to complete a task. We often say one whole task. You'll see what I mean by one whole. Now, I'll show you this more so that if you're studying, that when you go back and read this little sentence, that you remember how he did the problems. It says to create fractions of time that are equal to one whole. I realize that that probably isn't going to mean much until we do one, but indeed you will create these fractions of time again to equal one whole, and the one whole represents one whole job. Okay, so I'm going to put that swimming pool problem back up. Now, I don't think you're going to want to copy the whole problem, but we can kind of grab some of the key ideas from that swimming pool problem. So again, don't get overwhelmed with all the words again. But basically, the idea that it takes an hour to fill the pool and 20 hours to empty the pool. If you wanted to remind yourself of that. Oh, there's the music. Usually not the song you want to hear when you're like at the beach, right? Kind of like makes you want to not get in the water. Unfortunately, we won't be able to listen to the rest of that because it'll sort of be a little disruptive, but that was supposed to play when you were thinking originally. So what do we got here? Again, maybe just to remind you, 10 hours to fill, 20 hours to empty. These would be the only real key piece of information. And then, of course, knowing that these things are happening at the same time. Now, I know the word problem is new to you, and you're maybe just waiting for me to say, hey, here's how you do it. But look, you have a question, and anytime you're setting up kind of like an algebra problem or a word problem, we set where we think about the unknown. So I'm going to do the same thing. I'm going to say that H is this unknown amount of hours. Right? It's what we're trying to find. And now what we can do is we can create a fraction of time. And here's kind of the crux of the problem, where it is completely true that you will be able to complete 1/10 of the job per every hour. In other words, 1/10 the job will get done every hour for, how do I word this here, for would be the fractional, it'll be the fractional amount that's filled after H hours. It's a little long, but technically that simple statement, 1/10 of h, is the fractional amount of the pool that's filled after h hours. Okay, because you always will complete 1/10 of that pool every hour. Obviously, after 2 hours, you have 2/10 done. After 6 hours, you have 6/10 done. So it's a pretty basic idea that we can also apply to the emptying of the pool, because 1/20th of the job will always get done per hour. So 1/20th times h, that's the fractional amount. It's going to feel like we're writing the same thing, but it's the fractional amount that is emptied after h hours. It's the fractional amount emptied after h hours. Just kind of think about it. It's a basic idea. After 7 hours, 7/20th of the pool is emptied. After 15 hours, 15/20th. Because basically I just keep multiplying by 1/20th. Now, these two fractions can be put together to be a very simple equation. I'm also going to rewrite 1/10 h as h over 10, just because we can by algebra. And same thing with 1/20th h. I'm going to write that as h over 20. Now, these two fractions of time, which is what I meant by this phrase up here, these two fractions of time are working against each other. So we have to take away the work that this guy's doing, but they're trying to complete one whole job. And this really simple equation represents these two workers, in this case, working against each other, but we still kind of say working together to try to finish one whole job. And actually becomes a really easy equation to solve. Let's solve it. Realize that the answer is about to come forth, that some of you submitted in the little fun box. I hope you're just going to multiply by the really simple LCD. You know, if you look at 10 and 20 and the number 20 pops in your head, you're in the right place. If you weren't quick to get the number 20, we could break apart those numbers like we did yesterday. Now, don't forget that the number 20 gets multiplied to each numerator. I'm going to show it at least one time. But also don't forget that the number 20 gets multiplied to the number 1. I'll tell you that that is the most common mistake for students, to forget that number 1, but it also receives 20. Easy equation. You should be looking at this and saying 2h minus h equals 20, and bingo, h equals 20. Congratulations to some of you that got that. Don't feel bad if you didn't. It was just to be fun. That if you think about it, actually, anyone that got it, I'm not going to put you on the spot, but anyone that would care to volunteer, how did you get 20? Kind of thinking about this, just kind of thinking about it.
I just thought that, like, after 10 hours, it would have been filled up completely, but also would have drained halfway, so it'd be half full, and then just that again after 20 hours would be completely full.
How many times does the pool get filled, water-wise? Twice, right? So you think about what Brandon said, think about what's going on with the numbers. So indeed, you fill the pool twice, you know, it gets half full after 10 hours. I wanted to make a problem where you say, yeah, it makes sense. Let's do a work problem that I don't know if it'll make sense. I should say, I don't know if you would be able to figure out the answer just intuitively, but when we're done, it should make sense. I call it the homework problem. Homework problem. Trying to put as many flashing and moving parts on a screen as possible. Now, two things about this. First of all, this is not the way you normally do your homework, okay? Because this would be that you come with one homework assignment done. This would be 3 kids say, here's my homework, and you have one homework assignment done. So that's not normally how we do it. Now, maybe it would be how you do a group project, maybe, okay? The second thing is that we need some numbers. If you're like, how do I do it? Yeah, we need some numbers. And let's get those numbers from you. From you. How long does it take you to do a typical homework assignment in minutes? Don't exaggerate, just be honest. How long does it take to do, on average, a typical nightly homework assignment? Someone from sort of this side of the room.
Like stuff like last night took me about 25 minutes.
25 minutes. Someone from this row, homework, average homework.
And
I'm just going to take the first number you said. And someone from this side of the room.
15 minutes.
15 minutes. How long is it going to take for these kids to do their homework working together? I'm not going to give you a little piece of paper and have you do like a bonus, but before you set up the problem, I have a little survey. How many of you think that it's going to take greater than 25 minutes? We'll use X, greater than 25. How many of you think that it's going to be between, let's say between 10 and 25? Okay, good. I mean, I was making sure you're awake. I see a lot of hands. It's like, I don't know, if quick counting, I think maybe 9 people voted for that. I know the greater than or equal to signs don't make sense. I got too many equal to signs, but how about between 5 and 10? Anybody for less than 5? Well, you may or may not be surprised. Depends on how you voted. You think you can set this up? I'll get you started. It's always going to be, and to make this simple, it's always going to be X over your time. So it becomes a very easy format because it's always going to be. You can honestly skip a little bit of the thinking over here. Just don't forget what's going on. X is the minutes. And these people are trying to complete one whole job. And I hope you're interested in trying to solve it. It's not a bad little little thing to think about right now. What's your LCD? And maybe you got to use a calculator a little bit. It is a good little number question. You know, I hope that you got from yesterday's lesson how we can look at this and say we need a 5, a 2, and a 3. A 5, 5, 2, and 3. 5, 5, 2, and 3. That'll get you your LCD. If you've already solved it, you have the answer to our little survey. 150 gets to all three of these, and check that, all four of these. 150 gets multiplied to everything. These kinds of problems that just involve numbers are kind of nice. As we're able to get some pretty swift simplifying here. And so what's 150 divided by 31?
4.8.
Now, of course, let's not be silly. That's not 4 minutes and 84 seconds. That's not the way time works. In fact, it's 84th of 60, right? 84th of 60. It's approximately 50 seconds. But interesting. I think we could say it's not what you expected. How can this be? How can it take less than 5 minutes? I didn't script this, although I kind of know what happens normally with student answers. But how does this happen?
I think when we all voted, we were all like looking at like what the average time would be between three students instead of like if they all worked on the same thing together and like split the problems up, it would take a lot shorter.
I'm glad you're being honest about that, because that's spot on. Okay, it's not the average. It's not the average. But did you hear how Brandon said it's splitting up the problems? Now, do you realize how they get split up? What happens to Sir Speedy here? He or she has to do more. This person gets to take their time, and they get those problems right, but they take their time. So in less than 5 minutes, okay, everybody is done. Ready, set, go. Everybody's done, but they've completed a different amount of problems. That's called a work problem. Okay. I kind of just want to leave you with it works. No pun intended, but it works. The method. We did the swimming pool problem, which you were supposed to kind of see intuitively, but even in a situation like this, it works. So don't forget the little method. It'll be on a couple problems you can practice on the homework helper tonight. Okay, I'll put that homework helper on Classroom, but I want you to find the flex question that's on Classroom. That should be at the top of the stream. There's a flex question. Normally these are online, and this one goes back to that idea. Now, when you get that thing fired up, you will quickly see it's a flex question on multiplicity. Yippee, yippee, yay, multiplicity.